Hey everybody, it's Mr. N, and we are back with a first semester review video. These are multiple choice problems per request. You want a little bit more review with multiple choice, so let's do some of these. Let's start off with number one. These are no calculator allowed. So the figure above shows the graph of the differentiable function from x for 1 to 11. X is between 1 and 11, and the secant through the points 1, f1, and 11, f11. So these are through these points. For how many values of x in the closed interval from 1 to 11 does the instantaneous rate of change equal the average rate of change? All right, so we want to know when the instantaneous equals the average. Well, what we have to do here is, since we have an average, that would be this secant line that is shown right here. Instantaneous would have to be tangent lines that are parallel to this. So if I make one parallel, it's going to cross right here. I can make another one parallel to this, and that's going to cross right there. And then I can make one more that will cross right here. Oop, that line wasn't so straight. So there you go. We've got 1, 2, 3. Are there any more that I can draw? So let's see, if I draw a line, and let's see if I try to move it, is there anywhere else I can put this on here besides those three spots to make a parallel on this? No, that's it. So there's only three spots, so the answer to this would be 3. All right, moving on to number 2. Let's take a look at what we have here. All right, so then for number 2, it says a particle moves along the y-axis. Graph the particle's velocity vt is shown up here from 0 to 4.5. How many times does the particle change direction? So this is a velocity graph, and we want to know how many times it changes direction. Well, it changes direction when the velocity changes sign. So let's take a look. Here we've got a negative velocity, and then it changes sign right here. So it goes from negative velocities to positive velocities. Then right here we have a positive velocity to a negative velocity. So far we've got 1, 2 points where it's going to change direction. Then we've got a negative to a positive. There's a third point. And then here we've got a positive. It doesn't go below the axes. It does not look like it goes below the axes. So positive, only 1, 2, 3 points where this does change direction. So again, we are looking for velocity to change from positive to negative or vice versa. Okay, so let's do the next one. Let's take a look here, and let's slide this up. A particle moves along the x-axis at time t greater than 0, so its position is given by this equation. What is the total distance traveled by the particle over 0 to 5? So we have a position and we need total distance. But we do need to take into account when it goes backwards. So we have to solve for a velocity here. So let's go ahead and find a velocity, and that is going to give me the derivative of this x of t. So this will be 6t squared plus 6t minus the 36. Now let's set this equal to 0, and we can go ahead and take the 6 out and then factor it, and this will end up factoring into t plus 3 and then t minus 2. So that will give me at t equals negative 3 and 2 is where my zeros will be. So that's where it will change direction at those spots. So over here, we're going to throw out the negative 3 because we don't care about negative time. So we're going to start with the 2, and we're only concerned with 0 to 5. So over here, I've got 0, and over here I've got 5, and in this region I've got negatives. So that means it's going backwards. Over here I've got positives, and how do I do that? Well, I'm just going to plug them into my v of t equation right over here, right? So then I just plug in any number between 0 and 2, and I'll get negative values. Any number between 2 and 5, I'll get positive values. So I know that this is going backwards in this region, going forwards in this region. So I need to separate this out to be able to find distances. So in order for me to find distances, I need to take the absolute value of x of 2 minus the x of 0 in this first region right there, plus the absolute value of the x of 5 minus the x of 2 for that second region. And I'm taking absolute values because I need positive distances to find the total distance traveled. I'm not looking for displacement. That's a completely different problem. So let's go ahead and, or position where it ends up is what I should say. Okay, so now let's go ahead and do this. And x of 2, if I plug in 2 into this equation, I will get 6. Absolute value minus x of 0, I'll get 50. Plus over here, x of 5, when I plug in 5, I'll get 195. And I just did these by hand on the side here. And then x of 2 is going to be minus 6. So over here, I end up with 44 negative. Absolute value would give me positive, plus the 189 here, and that'll give me a total of 233, and that would be my result, 233. All right, moving on to the next question. A particle moves along the y-axis at time t equals 0, given by this position equation over the time from 0 to 4 for what values of the speed. We're looking for speed is to be increasing. Okay, so for speed, what I need to do here is I need to find both the velocity and the acceleration and compare those. So I need my v of t and a of t, and I need to compare, and for it to be increasing, these need to have the same sign. Okay, so they either need to both be positive or both be negative. So v of t from this comes out to be 3t squared by taking the derivative of this y of t equation minus 12t plus 9. I set this equal to 0, and I can take out a 3 here. I'll left with t squared minus 4t plus 3. I factor this, I'll get t minus 3, and then t minus 1 equaling 0. So this happens at t equals 3 and t equals 1. And I'll put that on a number line in a second, and in fact, let's just go ahead and do it right here on the side so I can show you. This is my v of t, and let's go ahead and put in 1 right there, 3 right there. And again, I'm going to test regions in between by plugging them into my v of t equation. And I will get positive here. So if I plug in 0, I'll get positive 9. And then here I will get negatives. You can plug in 2, and you'll see. And then over here, I will get positives again. And I'm only going out to 4 right there. Okay, so now let's find a of t. A of t, this takes a derivative again, so this gives me 6t minus 12. Set this equal to 0, I will get t equals simply 2. So let's put in the a of t right below it, a of t, and here is 2. Now let's go ahead and compare some regions. Now if I compare the regions here, I'm going to break this up into this one region, this second region, and this third region. And oh, I forgot to put the signs in. I forgot to put the signs for a of t. If I plug in a value here, I will get negatives, and if I plug in a value here, I will get positives. So that should help us out now. All right, so let's see where the regions are the same sign. They're the same sign right here. They're both negatives. Okay, and then again right here, they are both positives. So I have this being the same sign from 1 to 2. So t is between 1 and 2, and t is between 3 and 4. So those are the regions where I have the same sign, and your answer will end up being D. All right, let's move on to the next question. Over here, it says a rectangle has width W inches and height H in inches, where the width is twice the height. Both the W and H have functions of time measured in seconds. A represents the area of the triangle, following gives the rate of change of A with respect to T. So we need to find dA dt. And we are given some info, and here's what we are given. We are given that this width is related to the height because it's twice the height. We know the area of a rectangle. The area is going to be the width times the height. I can go ahead and substitute this in now because it makes the problem easier because I'm getting rid of a variable. So when I substitute this in, and the reason I'm doing that is because they want dH dt, so I want to keep the h, or dA, they want it with respect, looking here, this is how I know. Looking here, all of these are in h's, so I want to keep the h and get rid of the w. You could have done it the other way around, but the answer choices are not that. So when I plug this in, I get 2h times h, which gives me 2h squared. Now taking this derivative with respect to time will give me 4h dH dt, and this is in inches squared per second, and that matches up with answer choice D. All right, moving on to the next page. Looks like we have a shadow type problem. Let's see what it says here. A person whose height is m walking away from the base of a street light shown above. The height of the street light is L, and at time t equals second, the person is x feet from the street light. The length of the person's shadow is s. All right, let's put these values in. So let's go ahead and put some of these values in. Let's see what we got, what we're dealing with here, and let's take a look. We've got this as being L. Over here, this is x. The person's height is m, and the shadow distance is right there. Okay, so then it says the quantities are related by this equation. They gave us the equation. How nice. Where L and M are constants. Which of the following describes the relationship between the rate of change of x? So we need the rate of change of x with respect to time, so dx dt, and the rate of change of s with respect to time. So we need dx, in this case, we need dx dt and ds dt with respect to time. So I've got my equation over here, 1 over L, x plus s equals 1 over m times s. So what I can do on this is let's go ahead and set it up so I just solve for x directly, because my answer choices looks like they all have x's in there. So the way I'm going to do this is I'm going to multiply everything by L. So get rid of that. So over here I'll end up with x plus s equals L over m s, just like that. And now let's go ahead and subtract the s over to the other side. This way it isolates my x. So I end up with L over m s minus s. Okay, at this point, let's go ahead and differentiate. Remember, it said L and M are constants. So these two are constants. So I don't have to worry about the differentiation there. So what we'll end up with is dx dt equals L over M is a constant. So I just need to keep that. And I need to take the derivative of the s, which would just be ds dt as well, minus, I take the other derivative over there, ds dt as well. Let's see, is that one of our answer choices? It sure is, right there. So there we go, that's our answer choice, and it would be D. All right, moving on to the next problem. Let's take a look. A locally linear approximation of the differentiable function f at x equals 2 is used to approximate the value of f2.3. The approximation at x equals 2.3 is an underestimate of the corresponding function value at x equals 2.3. So it's an underestimate. So that's important for us to know that it is an underestimate. And right here, I will highlight it for us, that it is an underestimate of the value at 2.3. Now remember, linear approximation is we are taking a curve and straightening out. We're zooming in so close that it's going to make it straight. Well, clearly A is not the case, right? Because it's already linear. So that's going to give me an exact approximation. That won't give me an under or over. If I take a look at choice B right here, if I draw a tangent line right there, that's going to be above it, above. So it's going to be an overestimate. If I draw a tangent line here, again, that's above. So it's over. If I draw a tangent line here, okay, that's below. And that'll give me the underestimate. So that is our answer choice right there. And the answer choice will be D. A lot of these are coming out to be D's. Interesting. Okay, so now let's move on. Number 8. Which of the following does not yield an indeterminate form? Okay, so let's take a look. Over here, if I plug in 0, I will get 0 over 0. This is indeterminate. Over here, if I plug in 2, I'll get 0 over 4 minus 10 plus the 6. And that's just also going to be 0 over 0. This is indeterminate. Over here, if I plug it in, I'll get 0 over negative 1. Oh, that's 0. That's not an indeterminate form. Let's double check the last one. I will plug in infinity. I'll get infinity over infinity. That's indeterminate. So the answer choice here is C. That is an actual limit, and we don't get an indeterminate form. All right, so I just used direct substitution there. Okay, moving on to the next one. Selected values of the twice differentiable function f and g are, and the derivatives are given in the table. So it is twice differentiable, so we automatically know it's going to be continuous. Find the value of the limit as x approaches 3 of this equation right here. Okay, so let's go ahead and start with direct substitution. If I start with direct substitution, that's how we always do it. And if I end up with something that won't work, then I will take into account L'Hopital. So let's plug it in first at x equals 3. So this is going to give me 3 squared times f of 3. F of 3 comes out to be 2 right there, minus the 54 over here when I plug in g of 3 comes out to be 1 minus, and then just to show you I'm plugging in here, g of 3 comes out to be 1, and then I can plug in minus 1 over here. So then I will end up with, oh, this is cubed. I'm sorry, this is cubed if it didn't look like it. So 3 cubed, 54, times that 2 would be the 54, so I'll end up with 0 over 0. This is indeterminate, so now I need to L-hop it. So let's take L'Hopital's rule, and we'll take the derivative of the top and derivative of the bottom. Ooh, this is a good question, because be careful, you're going to need a product rule right there. So taking the derivative of the top will give me first times the derivative of the second, which would be f prime of x, plus the second, which is f of x, times derivative of the first, which is 3x squared, minus the derivative of 54 is a constant, which will be 0, and then taking the derivative of the bottom, I'll just end up with g prime of x, minus the derivative of 1, negative 1, which is 0 as well. So now let's plug in values again. Over here, I'll end up with 3 cubed times f prime of 3, which would be the negative 4, minus, or plus in this case, f of 3, so I'm doing direct substitution. I'm plugging this back in, the 3, right, because it's the limit as x goes to 3. So then where do we end up with? F of 3 gives me back to 2 times the 3, and then this is x squared, so it'd be 3 squared, all over g prime of 3, which comes out to be 2. And this ends up with being negative 108 plus the 59, all divided by 2, which is negative 27 as my answer, and that would be C. All right, let's move on to the next one. All right, over here it says, if g of x equals ln x and f is a differential function of x, which of the following is equivalent to the derivative of f of g of x with respect to x? All right, so we need to find something equivalent to that, and I'm given that over here, g of x is equal to ln x, and f is a differentiable, so we know it's continuous. Which of the following is equivalent to f of g of x? Okay, so looks like we're taking derivatives in our answers when I look at the answer choices, so let's take a derivative of this. Taking the derivative, we need a chain rule, so f prime of g of x would end up being f prime of g of x times, now I got to chain this, so this becomes g prime of x. Well, f prime, and I know that g of x is ln x, right there, times g prime of x. Well, let's find g prime of x here real quick on the side. That's 1 over x, taking the derivative of natural log. So this will give me 1 over x. So there we go. I can't break this down any further. Is this one of our answer choices? It looks like it right here. This is our answer choice. So this is f prime of ln x over x, which is the same thing. All right, that wasn't too bad. Moving on to the next one. Okay, these aren't so hard as of right now, but these are outstanding concepts that you need to know that'll help you, whether it's on the multiple choice or any of the other free response parts. But let's take a look here. Okay, which of the following functions is the chain rule appropriate method to find the derivative? So do we need a chain rule here? Well, I don't know if I like this question a lot looking at these answers. I don't know. Let's take a look. Over here, yes, you do need a chain rule. So this one, yes, you need a chain rule. And the reason why I say that is because the chain rule is always there. It's just we're multiplying by 1. So like, if chain rule appropriate, well, yeah, I mean, it's going to end up everywhere. This is a product rule, really, But you would need it. I mean, again, you would need a chain rule over here because you're just multiplying by 1. And this last one is really a quotient rule. But, I mean, if you work this out like this, then yes, you need a chain rule. You need a chain rule in it if you do it in that manner by saying -1 times this derivative times the derivative of the inside, if you do it in that manner. So, I mean, really, I don't like this question a whole lot, but really the only, I mean, I would say 1, 2, and 3, but the way it's presented, they're going to want you just to say 1 and 3 only, 1 and 3, because 2 is just, there is no 1, 2, and 3. I mean, if it was for all of them, I would select all of them, but that's the best choice I have. All right, moving on to the next one. That was not that good of a problem. Okay, that was from AP Central, so bad on them. Okay, moving on to the next one. Let f be a differentiable function if h of x equals that, okay, which of the following gives the correct for h prime of x? Okay, so again, this looks like we're going to need a chain rule again, so h prime of x, let's go ahead and do this. This becomes 2 times this stuff to the first power. Now I got to take the chain of this, so this becomes a 0 there, and this becomes f prime of 3x times, I got to chain that part of it, 3. So that's a tricky one right there. So this becomes 2 times all of these. It's not, it's going to end up being D. Looking at all the answer choices, it will end up being D. That's our, that's the one that matches what we have. So there you go. There you go. Okay, moving on. Let's take a look at the next question. Let's slide this up. What is the slope of the tangent to the curve that equals 5 at the point 1, 2? Okay, so for this one, it looks like we're going to go ahead and we need, this is going to be a differential, so we're going to need dy dx. All right, so let's go ahead and differentiate this. So this ends up being 3y squared times, I'm going to put y primes on this one, and which, remember, y prime is the same as saying dy dx. Okay, so then over here, I'm going to end up with that minus, and I'm going to need to do the product rule on this part, so it's going to be first times the derivative of the second, which would be 2y, y prime, plus the second, which would be y squared times the derivative of the first, which would be 1. And remember, I'm putting y, I'm not using negative because I put the negative on the outside for the whole thing, right? I just put the negative on the outside of this. All right, so this becomes plus 3x squared equals 0. Remember, I don't put x prime because that would just be dx over dx. It reduces itself out anyway. So let's see. Instead of at this point, since they gave me values over here, 1, 2, instead of solving for y prime, I'm just going to plug in. Plug in. It'll make the problem a lot easier instead of trying to separate all this out since they gave you values. All right, so this ends up being 3 and y is 2, so 2 squared times y prime, which is what I'm solving for, minus x is here 1 times 2 times 2 times y prime plus 2 squared plus 3 times 1 squared equals 0. So solving all this, I will end up with 12y prime minus, over here will give me 4y prime plus 4, that's a y, plus 4 plus 3 equals 0. So I end up with 8y prime minus 1 equals 0. So y prime is going to be 1/8. And let's see, is that one of our answer choices? There you go. All right, let's move on to the next page. Okay, here we go, number 14, and we've got if the sine of x plus y equals this, then dy dx. Okay, so we've got another differential, and let's see what we could do with this one. Let's see, if I take this right here, I'm going to end up with dy dx. Okay, so derivative of this will be cosine, and that'll be x plus y. And then I need to take the derivative of that inside. and that would be over here 1 plus dy dx, which you can write as y primes if you want. This will equal, so I'll just do this one in dy dx since I did the last problem in y primes. So this would equal 3 minus 2 times dy dx. So solving this, let's go ahead and let's go ahead and distribute this. That'll probably be the easiest way to solve it. So you end up with cosine of x plus y times, or this would be plus, sorry, dy dx cosine of x plus y equals 3 minus 2 dy dx. The reason I did that is now I can put the dy dx's on the same side. So I'll put them on the right side right here, dy dx, and this would be this one right here, cosine x plus y, and then I'll move this over so it'll be plus the 2. Hopefully you saw all the little manipulations I did there, and then I'll bring this other cosine over to the other side, so I'll end up with 3 minus cosine of x plus y, just like that. And now I can isolate my dy dx, and this would give me this 3 minus the cosine of x plus y, all divided by this cosine of x plus y plus 2. Let's see, does that match up any of these? And sure enough, it does. It matches up with D. It's just they put the 2 on this side, which is fine. Okay, looking at the next problem right here. We need the derivative of the inverse sine at x equals 1/2. Oh, okay, so we need to know the formula for du of the inverse sine of u. This is a formula that we were told to memorize. That's the square root of 1 minus u squared times du dx. Now, this one is a little easy because they're giving us the point. So all we have to do, this just ends up being 1 over root 1 minus 1/2 squared, and this du dx is just 1. So in this case, we will end up with letter choice B. I'm surprised they didn't solve it completely, but I guess they just wanted you to understand the formula and apply it. Okay, so moving on to the next one. Oh, our last non-calculator one, then we go to the calculator section. So let's take a look at what we end up with here. So on this one, it says the figure above, it's actually right there. The figure shows the graph of f prime, the derivative of the function f. Which of the four indicated values of f double prime the greatest? Oh, okay. So this is an f prime graph, and they want to know when f double prime is the greatest. Well, what is f double prime in relation to f? So f double prime are the slopes of f prime, and the greatest, so I'm looking for the greatest slope here. So if I compare the slope right there at A, let's do this in another color. If I compare the slope at A, it looks like that. At B, it looks like that. At C, it looks like that. And at D, it looks like that. Which is the greatest slope? Clearly, we can see that B is the greatest slope of that. All right, now moving on to the calculator part of this. So let's take a look here, and we can, I'm going to have my calculator on the side. I'm not going to open up the window. I'll just graph it for you on the side when I need to and explain. So make sure you have your calculators handy. So over here it says the derivative of a function f given by that at what, so that's the derivative. At what value of x does the line tangent to the graph have a slope of 2? All right, well, let's go ahead and graph this. When I go ahead and graph this, I'll just quickly put a little grid on the side, and I graphed it on my graphing calculator. Let's take a look at what we have, and we will end up, I'm just going to graph this portion of it right here, and I'll end up with this. This is the f prime graph right here, and I want to know at the value of 2, what will this correspond to, since the f at 2. So I'm looking for the f prime, what would be that value of the slope. So what you can do to find this x value, is you can set this equal to it. 2 equals 0.1 x plus e to the 0.25x. You can go ahead and solve. This might be a little bit difficult to solve. So what I suggest is you graph right here y equals 2 and graph this and find the intersection point right there. And when you find that intersection point, you will get 2.2869 comma 2. That is the intersection point between those two lines. So you're graphing the left side here and you're graphing the right side. Find the intersection point with your calculator by using that second calculate intersect feature, and you end up with 2.2869, which is this answer right there. All right, so pause if you had to do it by graphing each side. All right, moving on to the next one. The function f is given by this equation right here. For how many positive values? We're looking for the positive values of b. Does the limit as x approaches b equal to? This is very similar. So let's go ahead and graph this. I'm going to graph this function on my calculator, and I will get something that looks similar to this. So this is going to come down through here, come back up, come back down, and come back up. Something similar to that is what I will end up with. Now, here's what I'm looking for. I am looking for the limit as x approaches b to be 2. So I want this value of 2. So it ends up going just like that, believe it or not. This is the value at 2. So, but we need positive, so I'm not concerned with the left side. So I'm not really concerned with this, so I'm not going to count this point. But I am concerned what's happening here. Let's see if we could find this maximum with our calculators. If we find this maximum, this ends up being at 2.01. Whoa. So that means it will cross right there, and then the third part right there. Since that value is just barely above 2. And that's, I think they did that on purpose, just so that we can see that, and they kind of trying to trick us. So that means it will cross 1, 2, 3 times, and it said positive value, so I'm not concerned with that one, so 3 times. That's a tough one because they tried to trick you there. All right, let's move on to the next page. All right, looking at this, it says let f be the function defined above right there. For what values of b is it continuous at x equals 2? So for it to be continuous at x equals 2, that means I must have a value at x equals 2 for each of them, so that, and those values must be equivalent. So continuous at x equals 2, I'm just going to plug 2 in for x on each of these and set them equal, because they have to both be the same for it to be continuous. So that means I will end up with e to the 2b equals 1.5 times 2 plus b. All right, well, then I end up with e to the 2b equals 3 plus b. Solving this, I mean, if you want to end up, you could say b, oh, that's going to be difficult, because if you take the natural log of each side, that's going to be difficult to solve. So what do? We're going to graph each side and have our calculator do it. Graph the left side, graph the right side. So graph each of these on our calculators. So when I go ahead and do that, I will end up with a function that looks like this. I'll have this part of it right there, and then I will have this line that crosses it like this in these two spots. So I will find the intersection of each of these two spots, and this ends up intersecting at x equals 0.6469 and negative 2.9975. So that's the negative 2.9, and this is the 0.69. So again, I use my calculator to find the intersection of those two. That would be the easiest way to solve this, and that would yield an answer of D over here. All right, moving on to the next one. A lot of these seems like we have to solve with graphing. Okay, this one says, let f be the function defined by that. The IVT applied to f on a closed interval from 12 to 15 guarantees a solution to which of the following equations? Okay, so we're going to apply IVT to this. So let's go ahead and graph this, and just graph this region from 12 to 15. So when I do this, let's kind of put the grid here on the side, and you graph this, and you will end up with a function at that kind of looks like this piece. So this is 11, and this is 15 right here, and this is 12. So we're going to start at 12. We're only concerned from 12 to 15 in this region, okay? And we want guarantees which of the following. So over here, negative 10 would be down here. It won't cross. So looking at the next one, 0 would be right there, but that is not in my region because I'm only looking at this. Let me highlight it for you. See if I can use a highlighter tool. I'm only looking for in that particular region right there. So let's take a look at what we have. So these two are out. 4 would be right up over here. Let's see. Let me find some values. At 12, I end up with 1.081, I believe, or 4. Okay, and then over here at 15, I end up with 4.8574. So I need a value between those two. So that's probably the easier way of doing it. I should have done that to begin with. And that would yield, this was out of that, out of that, out of that. The only possible one would be from IVT. Answer choice would be C. So our answer choice is C. F of 4 would come right here, and F of 4 would give me IVT, guaranteed a value between those two. All right, moving on to the next one. This is number 21. Let's take a look here. A particle moves along a line where t is between 0 and pi, given by this position function. What is the velocity of the particle when its acceleration is 0? Okay, so I need a of t to be 0, and I want to know at what time does it happen so I can find the velocity at that time. Now, if you want, you can go ahead and just take the derivative of this by hand, and that's really not that hard. This would be 4 sine t, and then this would be minus t. So that would give me a of t as being 4 cosine t minus 1. So you could do that by hand. That's not difficult. Or you could put them in your calculators. That might take a little bit more time, but it was pretty easy to do by hand. But here's the key. I need 4 cosine t minus 1 to be equal to 0. I can go ahead and solve this. I will get a value of t equaling 1.3181. So now I'm going to go ahead and find V of this 1.3181 by plugging this into my calculator, or either way. And then I will get an answer here of 2.55. And there is your answer choice for this. All right, 22, we're almost there, we're almost there. Looking at this. If the derivative of f is given by f prime equals this, which of the following values of x does f have a relative maximum value? So I'm looking for a relative maximum. So I will go ahead and I'm going to place these on a number line. So let's do this. You know how much I like this number line method. I'm going to put this on a number line, and I'm going to find some values here. By graphing this equation and look for the zeros. Okay, so I graph this equation on my calculator. I find the zeros. This would be 0.9100, and then I get another value here of 3.733. Because when I graph this on my calculator, just to show you real quick, this kind of looks like this, and so then I found this 0 right there and that 0 right there. And along with this one right there, and that one came out to be negative 0.45 896. Okay, now I'm gonna, since this is my f prime right here, I'm gonna test regions in this. So I will test a region right here, I will get negatives. I will test regions here, I will get positives, and then negatives. This gives me positive slope to negative slope. There's a maximum. And then these are negatives, and then I test this region in here and I get positive. That's a negative to a positive, so this would be a relative minimum, and this would be my relative maximum. So the relative maximum occurs at 0.91, and there we go. All right, the graph of a function, y equals x cubed, changes concavity. Okay, so we got to find out when it changes concavity. Well, we can take derivatives of this by hand, or you could just put it in your calculator. And if you do put it in your calculator, you're going to put in y1. Let's put it here, and let's do it like this. Hold on, let me change my pen color. y1, put in the equation, okay, right there. y2 would be n derivative of that at x equals x, and then y3, or in this case, you would just put at y1, right? And y3 would be n derivative of y2 at x equals x. And you're looking for where it changes concavity. In this case, we need to find the 0. But again, if you chose to do this by hand, take the first derivative, that would be 3x squared plus 12x plus 7 minus, this would be 2. The derivative of cosine is negative sine, so plus 2 sine x. And then you would do this again, y double prime equals 6x plus 12. That's 0. And then this would be plus 2 cosine x. Plug this into your calculator and see where it crosses 0. We need, those are the possible inflection points. And since it's a possible inflection point, we need to test it to make sure it actually changes concavity. And that point would come out to be negative 1.894. And over here, I test this region, I get negatives. Over here, I test this region, I do get positive. And that for sure is an inflection point. And it does change concavity there. So that answer would be D right there. All right. And our last problem. Here we go. The volume of a sphere is decreasing at a constant rate of 3 cubic centimeters per second. At the instant when the radius of the sphere is decreasing by that, what is the radius of the sphere? And they went ahead and they gave us, how nice of them, they gave us the volume of a sphere. So let's take a look at what we have here, and we will do this. So I need a dv dt in this case, and they gave me, it's decreasing. So dv dt, they told me, is negative 3 cubic centimeters per second. At the instant when the radius is decreasing, they told me dr dt is negative as well, 0.25, and in this case, centimeters per second. So, and I have a volume equation, so let's take the derivative of that. So this becomes v prime is going to be my dv dt, and this would be 4 pi r squared dr dt. Well, they gave me some values. They gave me these, so I'm going to put in negative 3 equals 4 pi r squared, and they gave me dr dt, which is negative 0.25. So go ahead and solve for this, and you will get r equals 0.9772 centimeters, and that would be this answer right there. All right. So hopefully these weren't too bad, but the concepts here are extremely important. So thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.